Hello, I'm going to speak here in this video about the sequential function charts, which is the international norm regarding GRAFCET. So this is part 1, and I'll begin to speak about some fundamental concepts in point 1. Then I'll speak about evolution rules, provide an example, and speak a little bit about a tool called e-GRAFCET Plus. So this is a graph set, and we can see several parts. We got the initial step. Initial step is active initially, and then we got steps, the transitions, and the direct links and actions. So here, and also the transition conditions. These are the fundamental parts of a graph set or sequential function chart. And we can split this diagram in two parts. The structural part, which is this one from the left, and the interpretation part, which is this one from the right. So a step corresponds to an invariant behavior of a sequential system. It can be active, and if it is active, it is can be represented with a token, and inactive. And it can be also initially active. The initial steps are represented with a double square. This numbering is inserted by the designer of the diagram. The transitions may enable the evolution between several steps. So the transition may be enabled or not enabled. A transition is said to be enabled if all the immediately preceding steps, which I call here input steps, are active. So you can see here we got this transition. 10. We just have one input step which is active. It is this 3. So we can say that this transition is enabled. So there is a condition associated with each transition, which is called the transition condition, and may be true or false. So it can be an internal or external variable. So for instance, in this case, it was the state of a button. Button 1 can be the result of a logical expression. For instance, if this sensor is true, or this sensor is true and this button is on. Or it can be also always true. This is two different ways of representing that the transition condition is always true. This one and this one more recent. And it can also have associated counter values. So if, for instance, if the counter number 5 has a value less than 200, so this will be true. And finally, we can have non-Boolean variables, which are the rising edge of a variable and the falling edge from a variable. So this is a representation of the rising edge of the variable A, and this is the falling edge of the variable A. So we can have associated to each step one or more actions. So in this case, to step 3, we just have associated one action. It is action 1. So we have several types of actions. In this case, we are going to split it in two main types. The continuous is the first one, and the store is the second one. In these presentations, we are going to speak first about the continuous. So what is a continuous action? The continuous action is executed while the associated step is active. So it means in this case, when step 15 is active, and while it is active, these two actions, 1 and 2, will be executed. So the evolution rules are 5. The first one is called the initial situation. It characterizes the initial situation of the sequential system. So in this case, we got, example, we got 2 steps, 10 and 15, which are initially active. Okay, from this point, from this distance, the evolution of the graph set can be determined by other variables and conditions. The rule 2 regards the clearing of a transition. A transition is clear if it is enabled and the associated transition condition assumes the logical value 1. So in this case, in this example, the transition 4, it is enabled because the previous step is active, but the transition condition is false, so it is 0, so it cannot be cleared. So the next rule is the evolution of active steps and regards the clearing of a transition. When you clear a transition, this provokes the simultaneous activation of all the output steps and the activation of all the input steps. Once more, I'll be using here that, for instance, for this one, so transition 12, this is the input step 7, and this is the output step of that transition. So in this example, we have the transition 4, which is enabled because the input step is active, and when this situation occurs, it's going to be cleared, and this means that we are going to redraw this token and deposit the token in the next step. Rule 4 is about simultaneous evolutions. It means that transitions which can be simultaneously cleared are cleared simultaneously. So it means that we can have, for instance, one button which is associated to these two different transitions, and we can have the clearing of step 30 and 12 at the same time in different parts of the graph set, or even in different graph sets. So the rule 5 is about the simultaneous activation and the deactivation of a step. This is a convention, and we states that if during the operation a step is simultaneously activated or deactivated, it remains active, which is this case here. In this case, we got an initial step, which is 15, which is active, and also the step 2 is active. So it means that this transition 3 is enabled, and because of this synchronization here. So when this S becomes true, so what happens is that this transition is going to be clear. So we are going to take this mark from this point and this mark from this point, and we're going to deposit in step 5 and also in step 15. So it means that step 15, it was simultaneously activated and deactivated, so it remains active. Finally, the syntax rules are very easy. Just we have to have always an alternated sequence of steps and transitions. So we cannot have these connecting two transitions between them or two steps between them. So this is not allowed. So the example that I'm going to provide here is the classical toy problem with the trolley. We got this trolley here, and this trolley C1, and this trolley is in the initial position A, and we got also position A with a sensor. This sensor here detects if the trolley is in position A. This sensor B detects if the trolley is in position B. So when M is pressed, which is a button, the trolley C1 should go from the position A to position B and back again to A. This is a kind of cycle. The trolley got two motors, one to push the car to the left and another one to push to the right. So this problem is simulations for this problem are presented in e-GRAFCET Plus. I'm going to show you in a while, which is in this link here. And This is the representation in e-GRAFCET. In this case, it is in Portuguese, but we can also find it in English. And I'm going to present it here the solution for this problem. So it means that, we got the initial step 1. This initial step, it means we can put either a label that the C1 is in position A. So then we got this first transition, which is the transition condition is M. So when M is true, we pass to the next step. In this next step, we are going to activate the motor to the right until the car reaches this position here. When it reaches this position, it means that this sensor will be true, and we got the clearing of this transition, and then we go to step 3. In step 3, we activate the motor to the left until it reaches to the A position. So this actually is, we are going to see it, this is the first, when the system is turned on, it means that this step is active. When this variable is pushed, we pass to the next step. So the car goes to the right, it reaches B, and then it goes to the next step, and it goes back again until it reaches A. Okay, I'm going to just to show you this but before you can find all this information in this publication, which is in Portuguese. And now I'm going to show you the e-GRAFCET. The e-GRAFCET is this one. It is in Portuguese and in English. We can change here to English, and we can find here the notions. From elementary notions, you got some flash simulations explaining things, and then you got also some examples. This example is example 1, cycle with one sequence. Is this one? It is explained, and the solution is not really exactly the same, but as you can see here, I can just in this case the initial step is 0, not 1, but we can be also. So 0, it means that the car rests in the A position. So if I press this and now I stop it, so it means that this was true, so this transition 1 was clear, and step 0 was deactivated and step 1 activated. So this is a continuous action D, so it's going to push the car to the right. And now you can go and move this step by step, or push it and stop it again. You can see here that it's going to reach the B. When you reach the B sensor gets active. So this input from the PLC gets true. And so this transition was enabled, and now it's going to be cleared. So, and now it is going back again. So this is one cycle. You can try it different times and see how the movement of the trolley relates with the GRAFCET model of the sequential function chart and the PLC inputs and outputs. Okay, and with this demo, I'll conclude this video. Thank you for watching.